thank you everyone for joining the NVMe over Fabric appliances panel discussion. NVMe over Fabric has seen an incredible uptake in interest as a future data center connectivity solution over the past year, and especially since NVM Express, the standards body, released the version 1.0 spec. Still, despite the very strong interest, production deployments of the technology are really in an early stage. Today, I've assembled a world-class panel of industry experts on the technology to share with you a bit of their views on where the technology is heading, the possibilities and values of the technology, and a bit on what needs to happen in order for broad adoption and deployment to take place. So let me introduce our panelists. Kamal Haider. Kamal works at Toshiba Memory America with me as Director of Product Management for the Webscale product. Kamal has a long background in enterprise and cloud storage and data protection, having built storage applications, flash-based systems, and storage services for the cloud. In addition, Kamal has written 3 technical books on real-time systems. He has a bachelor's degree from the University of Massachusetts and an MBA from Santa Clara University. Manoj Wadekar is the Director of Hardware Engineering Team at eBay. He's responsible for developing eBay's hyperscale servers and supply chain. Manoj has over 25 years of experience in servers, networking, and storage, with prior stints at Intel and QLogic, among other stops during a long and successful career. Manoj has driven industry-wide Ethernet initiatives across multiple companies for IEEE. Based on this experience, he says he has learned how fun herding cats can be. Most importantly, he has a very serious message for the crowd, which is, go Dubs. All right. Yaniv Roman is a founder and CTO at Accelera. He's been a technology evangelist at disruptive startups for 20 years and now serves as VP of Engineering and CTO. His expertise is in the domain of high-performance distributed computing, storage, databases, and networking. Quite a combination. Yaniv has been a founder at several startups, including Accelero, Z-Round, and Picatel. And Nishant Lodha, who is by far the most photogenic person on the panel, as you can see from his OkCupid profile picture, which he kindly provided for the presentation. He's a product marketing manager for Marvell, which recently finalized their acquisition of Cavium. The rumor is they bought Cavium just to get Nishant. And he manages the 10 to 100 gigabit Ethernet NICs and smart NICs. Based in the San Francisco Bay Area, Nishant is responsible for the enterprise and cloud storage market, including trend analysis and analytics, hands-on technology analysis, and performance characterization for flash-accelerated applications. Nishant has authored a number of papers and is a common speaker at technology webinars. You can see some of his work in a recently published NVMe-oF and 25 gigabit Ethernet paper, as a speaker at Flash Memory Summit last year, at DPDK Summit 2017, in a Bright Talk debate on choosing an NVMe fabric. Did you win the debate, Nishant?
Always do.
Always does. And over the last decade, Nishant has evangelized Ethernet-based RDMA, storage use cases, and various telco cloud technologies. Prior to joining Cavium in 2010, Nishant worked at HP, Sun, and Intel. Nishant served on the board of directors for the Ethernet Alliance in 2016, is now on the board of the IBTA steering committee. So, to kick it off, please join me in welcoming Kamal Haider.
Just to start with, I was thinking about where the industry has been. I've not been part of the industry since the SCSI days, but I certainly have seen the industry and have tracked the industry and have built products in the industry since the fiber channel days. So I thought I would just ponder over where we've come both from a protocol perspective, transport perspective, and so on, and just reflect back upon that before I start my presentation and what we're seeing with NVMe and how amazing it is. So from a protocol perspective, SCSI is quite old. It was invented in 1978. It took about 10 years before we could now start to see fiber channel, and another 10 years almost before fiber channel became ratified. And then it took almost 30 years before we could start to see SCSI over IP transports and so on. And then FCOE came along and so on. What we're seeing with NVMe is quite remarkable. We're seeing the protocol and the transport coming together very, very quickly. We don't have these gaps of 20 years or 30 years for things to catch up on. And that's really powerful. The low latency that we're seeing, the very high performance we're seeing is a huge benefit to applications, both in the enterprise space, in the data center space, and we're also seeing implementations in the cloud space. The other thing we are seeing very, very quickly is how these additional fabrics are catching up. So now we have, of course, we had Rocky, we are seeing TCP now supporting NVMe as well. And this is all happening in a very, very quick, short time frame. And that gives us a lot of benefits. Something else that this low latency provides us with is if you have stacks that have a very high latency amongst themselves within them, those stacks now get exposed because when your latency with NVMe is so small, if something is a big latency adder, which was hiding behind milliseconds of latencies of the transport in the past, all that stuff gets exposed now, because now we are talking about latencies in the microseconds area, as you know. So that becomes very important as you start to build products, as you start to have these environments. You need to carry that low latency end to end. We are also seeing native OS support for the protocols come up very, very quickly. Linux supporting it now, 4.9 plus, and other OSs following that. Something else that we are demonstrating at the show, and we'll talk about on the next slide, is also the concept of disaggregated flash. If your local latency versus your remote latency, remote not meaning thousands of miles away, but remote meaning within the same data center infrastructure, within the same rack, talking to the same top of rack switch, if there's very little difference between the latencies of a directly attached flash device versus a flash device over the network, if there's very little latency difference, what can you do with that? And that's what we're calling disaggregated flash. And we certainly are demonstrating some products here, and we can provide more detail for you. And then with NVMe, of course, what we are seeing is in different types of architectures, whether it's enterprise data center architectures or cloud architectures, we're seeing very, very quick adoption in multiple architectures, and that's really exciting for us to see. Any questions so far? So just wanted to provide a quick historic perspective versus where we are now and where things are going. Coming back to my earlier point about disaggregated flash that I briefly talked about, we've seen that story as well. I'm calling this the consolidation movie. What we saw almost 18 years ago when fiber channel was catching up, when SAN was catching up, what we saw was a bunch of SAN islands that were getting consolidated. At that point, we had different application islands, different organizational islands, and fiber channel allowed us to consolidate them over at first a single protocol, and following that, multiple protocols. As you know, iSCSI came on the scene. Of course, FCOE came up and tried a bunch of things with FCOE as well. We also saw vSANs come up from multiple vendors. We saw, for example, support end-to-end for security, even in new protocols, relatively new protocols such as fiber channel. So all these things caught up over a period of time. And then we saw services that were now being deployed over these fabrics, disk services, array services. We could start to see even QoS appear within these services. So I believe that as this industry grows and as NVMe catches on, all of this will start to happen, and we'll see that also in the NVMe world. And how this relates to disaggregation is something that couldn't be done at that point, which we'll be able to do now when your latencies are so small, not much difference in latency between directly attached flash versus flash attached over a network, whether it's RDMA, Rocky, TCP that's catching up now. If the latencies are very small, you'll start to see even disaggregation happen, which did not happen in that world before. So that's a prediction that I'm making, of course, but we'll see that happen, I believe. Any questions? Good. I only had a very short presentation with a couple slides as an introduction. On to the next speaker, please, Manoj.
I'm going to go through some of the things just to kind of set the context for what I'm going to say, because of course track is NVMe storage appliances and arrays, and we have hyperscale infrastructure. So I'm going to really focus a little bit on the hyperscale infrastructure, step back a little and say why, what is relevant for us, and then share some thoughts that I think we are going in that direction, or what we think we could be going in that direction, or industry could help going there. So this is just kind of a stepping back. eBay has a large, or many of the hyperscale infrastructure companies have two buckets of infrastructure. One where there is a mission critical infrastructure where we'll see the enterprise like, we'll see storage arrays, appliances, etc. There's a large infrastructure which is our hyperscale infrastructure. This is where everything is servers, everything is local storage today. This is where you'll see major, the way we look at it is that we like to build servers which are really optimizing our infrastructure for those applications. And these are well-known applications for our usage, and we try to optimize it. So these are the general buckets of categories that we design the servers for. You'll see the search, and this is, every company has different names, maybe slightly different services, but kind of fit in the same buckets. You have search, you have Hadoop, your big data, there are front-end products, they may be running VMs, or they may be running containers, or other kind of serverless technologies. You'll have some large object storage, depends on the company. You may have very large object store or relatively large object store. Then databases, whether this could be NoSQL databases or different categories of SQL-like databases. And then, of course, the growing use case for deep learning and AI. So we design servers for all of this. And the important thing is that once you design these servers, they are going to be at a very high number of servers that you're going to design. So we look at how do we define this, because all the efficiency as well as the spend as well as the performance is heavily dependent on it. Considering an example for eBay, for example, our listings and sellings are going to continue to grow year over year. And our goal is to basically define the infrastructure which supports that from performance point of view, from capacity point of view, and make sure that we are efficient every year, because the spend is continue to increase as the growth happens, but you want to make sure that we can do much more of that. So there is always a balance that we are trying to match. We want to really design the servers which are really optimized for those applications. You may have a server that is designed for search, and you want to make sure that your search per second is going to go up. You have an application for server for Hadoop. Our goal is basically to make sure that we balance between storage and performance, because you're going to run MapReduce or equivalent technologies on Hadoop. And so you are looking at a data which is at much larger scale than what search would be looking at, for example. Databases, here databases would have requirements for performance of the storage. Compute requirement will be relatively lower as compared to search. So there are different categories, and you're trying to design server. Ideally, you would like to have just one server that I can deploy for all these applications, which is great from an efficiency perspective. It's great from my cost perspective, perhaps, but it ends up that's not how it works out, because you optimize the server for one type of sub application is going to be suboptimal for other, and you end up buying a lot more, which is not exactly efficient. And also the performance may not be exactly what you would achieve. If I define the server purely with hard disk, which may work for the big data, but won't work for my databases. So you really are trying to map it at a design goal, which is really more balancing to say how we achieve the global optima. Now, to achieve the global optima for a data center, it's kind of difficult because you can't really let go of local optimas for each applications. So that's the balance that we end up doing. But important thing, of course, I say that you have to keep that scale in mind, that we're not buying at nodes anymore. We're buying at racks. We're going to buy hundreds of racks for each application. So we really have to design something keeping racks in mind. So they are all similar, very homogeneous, racks with the servers and the networks and everything loaded on that. The challenge that happens with that is you are really trying to define a rack, and if you find a use case which slightly changes based on a particular requirement, which may be storage or memory or CPU, you have a challenge of defining a new server because you're defining a new server for that rack. And this is where the trade-off starts becoming a challenging. I may have designed an application which has, let's say, a certain amount of storage requirement and is fine with SATA SSDs. But I got another application which requires NVMe drives or maybe different kind of capacity on that. And this is where you end up defining a new server. More number of SKUs makes it more difficult, or because now you're reducing and you're fragmenting your infrastructure. So one of the things that we're looking at saying that we really have to start looking at how do we define the whole thing more rack as a compute, so they have more flexibility. Defining a server takes almost a year, but defining a rack takes much less shorter time than that. I could define how much cores I need, how much memory I need, and how much storage I need. Memory is difficult to disaggregate from the compute. It's the performance requirements and latency requirements are too high for achieving to take it over the network, at least at this point of time. However, storage, and this is how now I'm connecting back to what the topic of the today is, which is the storage, can I take it over the network? And contention would be yes. I think there is going to be certain limit to which you're going to start running into the latency issues or any other kind of issues. But within the rack, one could start considering I got compute and memory and I got a storage. Allows you a flexibility of defining what's my compute capacities. Because when we buy a rack, we are looking at how many total cores are there, how much memory is there, and how much storage is there. Of course, it's more complicated than that, but I'm just simplifying for the sake of discussion today. So if we can make sure that we can separate out the storage within the rack now with the same compute nodes and same storage node potentially, you could start separating out and build out different racks, which may allow me to achieve those local optimas that we talked about for a particular application without compromising the global optima. Giving an example, let's say I defined a storage server with a 4 terabyte and somebody needs 6 terabyte. They may end up buying a lot more nodes with the 4 terabyte just because they need more storage capacity, which is going to waste a lot of cores and a lot of memory, which they may not use. And that's where the local optima and global optima start crashing. But if I had a rack definition, which allows me to have certain number of compute and storage and change the ratios, then we can achieve a lot more efficiency in the infrastructure without compromising the performance needs for each application. So I think this is where we are saying that, rack local storage kind of starts making sense at this point of time. And then I think the locality, whether it's a rack or whether it's in the data center or whether it is across the data center, it really depends on the needs of application that each company or each application has. If somebody requires a specific latency which can survive only one hop network, you really need to be one hop within the rack. If it's something that survives 3 hop network or 5 hop, you can be within the data center. Depends on how your network design is going to be. So it's really critically important and critically dependent on that. I put Ethernet there as a fabric. Of course, that shows my bias, but it also shows the reality of our infrastructure. That doesn't mean necessarily it will work for everybody, but for us, for hyperscale, we really are very, very Ethernet heavy. There is very less other fabrics. It's just basically integrating into the overall hyperscale methodologies and DevOps models. That may be difficult to do with other fabrics. So, of course, my bias is on Ethernet side. But think of a rack as basically lots of compute nodes, which are compute and memory heavy, and some storage for maybe boot and basic services or the common requirements, and then storage, which is disaggregated within the rack. My preference is Ethernet, of course. What this allows us to do is basically kind of a recapping why we went down this path is, of course, we are going down this path is basically the right sizing, because this can allow us to have the clusters which has now same nodes that we designed, but allows us to right size for how much compute and how much storage that you need within that rack. It does allow the wastage of capacity, which basically my improvement of my CapEx side, but also improves the performance because I can provide the performance that otherwise would have gone across multiple racks. It allows me to have within the rack. And this important part is, of course, this is a slightly different point here. There is a compute and storage scaling happens independently. If you look at last 4 years, the cores have, let's say, doubled. But if you look at the per node, basically, but from how many cores you can put in the CPU, but storage has more than quadrupled. So today, if I just keep on doing the storage and compute scaling at the same time, it becomes difficult for me to catch up on that. Second part is basically the storage densities are growing so much that trying to define a local storage for compute with utilizing that full storage capacity is difficult. The performance also. If I put NVMe drive in one single server, which has very high performance of storage, it may be difficult for me to go beyond a drive, and that becomes a failure point for me because you got a single drive. Whereas if I had the storage capacity separated out, allows me to use that higher performance, it allows me to have higher storage capacity. And these are the other advantages why I can start looking at much larger scale than looking at a particular single server node. So to conclude that and connect it back to our topic, now the question comes that if we wanted to do this design, we need a technology which allows us to do disaggregated storage from the compute. And then I think NVMe over Fabric, various technologies are really a good solution in that direction, because the performance of NVMe drives is extremely critical and allows us to use the higher densities that are coming from the flash. We really have to continue to scale the performance along with the storage densities. Otherwise, the performance requirements can start dominating the how we use that thing. So those are the important things for our use cases. Will continue to differ, and we'll talk about it as we start getting into the discussion. But NVMe over Fabric, all the technologies are important for us. It's of course Ethernet heavy focus on that technology. That's it. Thank you. If you had any questions now or later is fine. So today, if I understood your question correctly, today all of our stores, most of our servers for hyperscale infrastructure is, in a way, you can call it as hyperconverged. In the sense, you have compute and a storage on the same server. The challenge with that, of course, as I said, is really how do you define that server? How much storage capacity do you have? How much compute capacity do you have? There is an expectation, there is an ideal scheduler that is running across the data center, which allows you to optimally utilize the compute and storage resources available on each node, which becomes extremely difficult scheduling problem. It ends up happening that as you start deploying this infrastructure, you get silos, you get targeted deployments, and that results into inefficiency across the data center. So it's a right story. It requires schedulers that tend to become complicated in the real deployments. Again, that's my personal opinion, obviously.
I'm Yanni Bromem. I'm CTO for Accelero. I think talking after Manoj is actually perfect from my perspective, because what we're doing as a company, and I'm not going to go into the commercial side too much, but just as we're building a software-defined storage layer, dedicated or designed specifically looking holistically at large-scale data centers. And a lot of the things that Manoj sort of raised as issues that he sees are things that sort of we grapple with also as we build out our system. One of, I think, the most complicated issues that we've seen today is how essentially is Flash deployed today in those large-scale data centers. And that's sort of one of the things that we've been looking at and trying to improve with our solution. In the slide we're showing, sort of we depict the two main things that we're seeing, and I think in a way that sort of Manoj is starting to talk about a third option. On the left-hand side, there are the all-flash arrays, and in the previous session, I think a lot of the people on the panel were talking about how fiber channel has been historically used, and iSCSI to some degree has also been used in order to connect Flash as discrete appliances that serve out, and then they can serve a whole bunch of different servers. They provide shared capacity, they provide performance that is aggregated in a box and can be shared across multiple servers, and in many ways solve the problem of how do you scale out capacity and storage at different rates as according to your needs. It does dictate in a way which fabrics and networks involved, and there was a lot of discussion around that in the previous session. The problem with the all-flash arrays at the end of the day is that you end up with this box that can work for some of the servers, but it becomes a big issue of how you manage them together. How do you turn that into a pool that can serve a larger data center? And how do you keep the efficiencies at scale? One of the things also that was mentioned was, how do you keep your costs down? How do you make yourself very efficient in the sense of cost per gigabyte or cost per IO that you're generating out of those boxes? How do you keep scaling up the networking in order to meet your growing needs? And with those, all-flash arrays tend to have an issue. So if you want to pool many all-flash arrays together, you start doing multiple network hops to get to your storage. So you start getting latency hits. It's expensive at the end of the day per IO or per capacity that you store there. So if you look at a lot of the larger data centers, you won't find any all-flash arrays in there because it just doesn't make economical sense for them to bring them in. What do they do instead? A lot of them have gone to in-server SSDs. A lot of them are just saying, okay, we'll put some ratio of storage that'll be used locally within our compute zone nodes, and we'll work around that from an efficiency perspective, and we'll add in software layers to go and compensate for what we're missing. The Allflash arrays on the left-hand side have a wide variety of storage services that help ensure that the data is stored as efficiently as possible. That is, from a large degree, the most important storage service they provide is that they protect the data. If there's a drive lost, the data is still protected. If there's a controller loss or a server loss, this data is still protected. When you go to in-server flash, it becomes much harder to do those things. One of the options to doing that is running converged software. I think there was a question about that a moment ago. But at the end of the day, if you really want to get the highest performance, the most efficiency, you buy the fastest NVMe drive, you put it in your server, and you have the best performance that money can buy. The problem is, okay, so what do you do then about your storage services? And how do you pool that storage? How do you work around the capacity to compute ratio, unless you want to go and tailor make every one of your servers and define how much storage you need in each one of them? You end up having this issue of how do you scale your capacity, your storage capacity or your storage performance without scaling the compute in the same way and still maintain a small number of SKUs, or how do you build out your data center efficiently from that perspective? NVMe flash. So at the end of the day, when you start moving over to NVMe, you're actually intensifying your problem, because on the one hand, if you use NVMe locally, you've got all this IOPS, you've got all this capacity that's starting to come in at better and better prices, and it's all within that one server. So if you have a whole bunch of servers and one of them needs a lot of storage, needs a lot of IOPS, and so you go and say, okay, I'm going to set my bar to that level. What happens to all the other nodes that don't really need that level of IOPS? You have a lot of stranded IOPS. What happens if the capacities are different between the different boxes? You end up having that kind of same scale of capacity versus compute problem. But again, it intensifies because you're either buying larger capacities because in some cases you need more and more capacity, and it also intensifies because you have more IOPS that you could potentially use and are supposedly are going to waste. And people will look at you and say, okay, you've got all this IOPS and you're still saying that you're under capacity on storage in certain areas. It's really this totally shared nothing architecture has benefits from an ease of use perspective, but it becomes hard to go and make efficient use of all that technology that you've suddenly got. So there's really, the way we see it, there are really two options for distributing NVMe within your data center. And Accelero as a company, we're building out our storage-defined software so we can actually cater to both of them and to combinations of the two of them and be really efficient about that. On the left-hand side is keep your storage as is. If on the large-scale data centers, keep the storage within the servers, but build out a converged layer. And it doesn't matter if you're running hypervisors and whether it's hyper-converged or it's just bare metal machines that are doing both compute and storage. But keep your storage nodes, keep your storage devices within your compute servers, and have a layer of software that knows how to pull them together and allows you to access remote storage very, very efficiently. And stuff like NVMe-oF fabrics is key to that. If you can go and disaggregate your storage from your compute logically and use the entire compute within your rack for all the compute within that rack, and go and mix and match pieces of the storage and turn them into virtualized volumes and add on data services such as data protection and other data services as well, then you have a great solution. It's great from a performance perspective because you're pooling all your PCI lanes and all your networking resources and using all your storage resources to the utmost. In that way, you can get the best of both worlds. On the right-hand side, there's another option, and I think this was the one that Manoj was sort of pushing towards. You can go and say, I can now, thanks to high-speed networking and high-speed fabrics, I can go and concentrate NVMe devices into top-of-rack storage boxes. I've got enough network capacity today with 100G networking coming in, and people are talking about doubling that soon. There's enough networking capacity there to go and make the drives look as if they were local using stuff like NVMe-oF. It's got benefits in the sense that I can manage the two things separately. So I can go and I can scale out my storage separately, just need to scale out the storage on those boxes, on those specific boxes without having to touch the rest of the servers. And from an availability perspective, if I've got a very stable environment, then the left-hand side is good. If my environment is not that stable in the sense that the compute nodes need to be updated a lot and there's a lot of reboots in the system, the right-hand side has benefits from a operational perspective. So what we're seeing is a lot of customers coming into us and saying, okay, so guys, what do you think is the right thing to do? And a lot of it, to a large degree, is operational. So what serves you well in the sense of, okay, how dynamic is your environment? How much performance do you really need? Is top of the rack enough for you, or do you actually need the full performance that you can get from going to a converged solution? Those are the kind of questions that we grapple with them together. And again, our software really does cater to both of them. Looking at it again, I think we try to summarize here some of the points. What are the challenges for web-scale applications? So really, more and more web-scale applications are built as applications that run not on single nodes, but on racks and racks of machines. They want to reach maximal efficiency because they're using so much compute resources. Every ounce of efficiency is important there. They have to be always up. You have to be always on. You can compensate for any failure through software within the application layer itself. But if you can rely on your storage to a larger degree and provide data protection within the storage layer, you can make it much easier for the application, of course. Scalability and performance, meeting both of those things at the same time, is something that they grapple with. And then the newer workloads that are coming in, and some of those were mentioned earlier, real-time analytics, artificial intelligence, are making those challenges even more intensified. In a way, the hyperscalers today are really taking HPC-like workloads and bringing them into commercial racks and trying to make them work operationally in a commercially viable environment. And that really puts a lot of load on the storage layer as well. When you look at the converged environments where you go and you put the storage and the compute together on the same nodes, that gives you a great amount of benefit if you can manage it operationally. You get the ability to go and say, okay, I've got the highest end drives, and I'm using them at maximum efficiency because I'm sharing them and pooling them across my entire compute workload. And so if there are islands or hotspots, they can make better use of the entire resources of the rack and not only their local racks. And if you take it to the extreme, you can look at all the three different options. In-server converged, in-rack converged, or even cross-rack converged environments. Alternatively, top-of-rack storage, and then sort of to the taking that top-of-rack concept even to a wider degree. Go and say I've got rack storage, racks just for storage, and everything is totally composable across a data center. And with that, I hand over to Nishant.
So my name is Nishant Thoda, and my current owner's name is printed on my shirt. That's Marvel. And what I want to talk to you guys today is about the well-connected NVMe. Right? All the illustrious speakers before me, they talked about kind of moving storage away from compute, and then the network plays a strong role in that. And so I want to put a little bit more perspective and my own thought process into what do we mean by a well-connected NVMe. So and I wanted to draw some parallels from real life, our own real life, as to what are the things that people see, customers see, vendors see around connecting NVMe to storage. Think about yourself. How do you connect with other people, right? Some people like to connect with others in the virtual world using Facebook. Some people are more LinkedIn guys. The younger people use Instagram or Snapchat or things like that. My daughter doesn't do Facebook. She only does Instagram. And see, some of these decisions on how to connect to others are based on a variety of factors. Those factors are: what are you most comfortable with? What is your own skill set? Whom are you interacting with? All of these are options for you to connect to others. The same is practically true for the data center. When you are scaling out NVMe across the data center and you're connecting it to whether containers, your virtual machines, or your business applications that run on enterprise servers, you have a choice of various different type of networks that you want to use. It could be RDMA-based networks. It could be Ethernet-based RDMA networks, Rocky V2, Rocky, iWarp. It could be more boutique fabrics. It could be InfiniBand. It could be Omnipath. It could be something traditional, fiber channel, right? And over my next few slides, I'll kind of try to paint a picture as to how do you make the choice as to which fabric do you use. Every fabric, just like every other social media platform, has its own ways of doing things. It's most of my presentation will talk about what are you most comfortable with, what is your skill set, whom are you talking to, what are your security implications, and such. Okay, so a little bit let's before we jump into the actual meat of the decision-making process on how to connect your NVMe to your applications. Let's talk about what's happening around in the data center, because end of the day, even though this is Flash Memory Summit and we all talk about Flash and NVMe over fabrics, but inside the data center, there are many other trends going on concurrently. Let's look at the Ethernet speeds and feeds kind of happening around there. And I have two charts here. One is kind of looking at overall how the Ethernet speeds are transitioning and then focused towards the cloud. And I think it's no surprise to all of you guys that today on the server side, 10 gig Ethernet is the dominant interconnect, right? Slowly transitioning away from 1 gig, 10 gigs becoming the primary interconnect on servers. It could be 10G base T, it could be SR, copper, or blades, but 10G remains the dominant interconnect. 25 gig is taking shape. A lot of customers moving away from 40 gig Ethernet, deploying 25 gig Ethernet. And this is the first time, as you see in towards the tail end of the chart here, you see multiple colors on the chart, and that's what you see is that this is the first time in the Ethernet industry that I have looked at that so many Ethernet speeds are in play together, right? And how all of this ties together, and I'll get back to that in a second. Let's look at what is happening on the Ethernet switch side of things, right? The good part about the Ethernet switching fabric is that that speed transition is happening much faster. Although there is a lot of 10 gig on the servers, the top of rack switching is quickly moving to higher speeds, 100 gigabit Ethernet. And that is critical when you want to scale out your NVMe across the data centers, because access to NVMe or fabrics requires a high-speed network or a high-speed Ethernet network or a high-speed fiber channel network. It's important to understand what's happening in the data center. Does data centers have the infrastructure for high-speed fabrics to make sure that your NVMe drives can scale across to your different types of applications? And that is definitely happening. Like I said earlier, let's look around in the data center. What else is happening, right? Beyond everybody adopting Flash and hard drives going away and Flash becoming faster and faster, a couple of things going on. First, within the Ethernet networking side of things, there's a new type of Ethernet NIC around there, and that's called a smart NIC or a smarter NIC. And then certainly there are regular NICs. And a lot of these smart NICs can be defined as a standard networking functionality plus some kind of compute embedded on it. One of the most popular use cases that smart NICs are delivering is that they have the capability to provide a single solution that can connect to multiple NVMe drives, especially for JBOFs, FBOFs kind of scenario where there is a little bit of management needs on that box. You don't need to provide a whole set of storage services, but still need some control plane. Definitely open. The industry is becoming more and more open. Most standards are open today. There's OCP happening on the server side of things. It's Open 19 driving more efficient racks and connectivity. There's also the hybrid cloud happening, and a lot of us kind of serve into the standard enterprise, which is slowly moving to the hybrid cloud. And what is happening there is that both the VMware as well as Microsoft are delivering a passage for enterprise customer to slowly move to the cloud while still trying to retain some of their existing infrastructures, their own disciplines and things like that. And both VMware and recently with Microsoft Azure Stack are going in that direction. And a lot of these architectures, both the VMware Cloud as well as Azure Stack, rely on disaggregated storage or even converged, hyper-converged storage. Is definitely, we are all here talk about storage. Is all-flash arrays happening, rapidly moving and getting stronger and stronger in the enterprise. JBODs are moving to JBOFs, FBOFs. That's definitely happening. And not specifically related to the storage side of the world, but the SDN is happening big time within the enterprise data centers. And all of this is leading to a software-defined data center where there is pools of compute, there is pools of storage, And all of that is orchestrated and managed. And going back to the point that Manoj was making is that what you don't want to marry all your flash to a single server and then figure out how to scale that as your applications grow, as your choices that you made today and how they will be applicable a couple of years from now, where our applications have changed, your workloads have changed, and software-defined data center definitely is helping out there. So how do you scale out NVMe across the data center? There is a choice of PCIe, and certainly everybody talked about as being one of the most efficient ways. But that's just like me communicating with all my family, not via any social media, via phone calls and things like that. Yes, that's the most efficient, that's the most secure, but is that scalable? Right? Definitely not. And that's why my previous analogy to social media, there is a lot of fabrics out there, right? And just in the previous session, there were questions on fiber channel, Ethernet. How do you make the decisions? More the choices, more the confusion. Let's see what the choices are. Today, in terms of enterprise customers, fiber channel is the dominant interconnect for all flash arrays. Over 70% of all flash arrays are connected over fiber channel. It's not the fiber channel guys are sitting around idling their thumbs. They are reinventing fiber channel to go to FC and NVMe. And if some of you guys were here in the previous session, the NetApp guys talked about how their newest array is leveraging FC and NVMe. So there are customers who are comfortable with fiber channel, who are comfortable with storage area networks, and are moving as they adopt NVMe to the next generation of fiber channel, which is FC and NVMe. FC and NVMe did get standardized, I believe, earlier last year. This is definitely the RDMA-based fabrics, and there are one too many of these. There's definitely commonly talked about Rocky and Rocky V2, right? There is iWarp, a strong contender for Ethernet-based RDMA fabrics. There is other boutique fabrics, like I said, it could be InfiniBand, OmniPath. They all have their space today within the data center. They are all fabrics that have been used in the past for many other use cases. RDMA, and especially InfiniBand, primarily being used in HPC use cases. And they're all maturing and transforming to move storage and NVMe across the wire. Ethernet by itself, at least for the enterprise customers, for brownfield deployments, is yet to gain, in my opinion, in my own personal opinion, the trust of the storage guys who are extremely cautious on where do they put the storage data on and how that is transported across the wire. Well, FCOE is another fabric option for scaling out NVMe. I haven't personally met many customers who are still excited about FCOE. If you find one, please drop me a note. And then finally, there is NVMe over TCP, and that's the latest kid on the block. Who is not familiar with TCP, right? All our networks run on TCP. We have relied on TCP's robustness, retransmissions, everything that TCP brings to our table for literally every application out there, right? And why not extend NVMe over TCP? And like Kamal said in his talk, there are a couple of sessions going down in the hallway which showcase how TCP is yet another choice for moving or scaling out NVMe across the data center. The key thing about TCP is that unlike RDMA, it does not require a complete rip and replace, right? You have older servers with older 10 gig NICs, your 1 gig NICs, they want to access a high-speed all-flash array with NVMe. RDMA is not a choice for them. You can buy fiber channel for them if you're comfortable with fiber channel, right? TCP is always an option, okay? So finally, how do you go about, and that's my last slide, how do you go about making a decision as to what fabric do you use to scale out NVMe, right? And there are three things that I would like to say about it. First of all, that choice should not be based on the fabric's performance itself. There are a lot of vendors out there who are going to make a claim and come to you in their presentations and their talks and their marketing material. We provide less than 1 microsecond latency. We provide half a microsecond latency in our fabric. Don't let that decision be the only decision that you make when you choose a fabric for scaling out NVMe. The end-to-end latency, how much your applications care about latency. What is the latency introduced by the software stack? Look at the bigger picture rather than looking at just the fabric's microsecond latency. Second, You have your own culture in your companies. You have your own installed base. Let's say you are a baseball fan. Let's say you're a football fan, right? It depends on what strengths you have, what skills you have, what is the culture in your company, what is the fabric you have relied on in the past. Talk to that vendor. There is a next generation of that fabric coming out that will help you scale out NVMe over the fabrics, right? Stay comfortable unless it's absolutely necessary with what your organizational strengths are. What's the fabric you have trusted? If you are a fiber channel customer, look at FC NVMe. If you're looking for greenfield deployments, you're looking to consolidate the fabrics, look at Ethernet. Even when you look at Ethernet, do you want a full rip and replace to RDMA based NICs? Maybe not. Maybe you don't have the skill set to deliver a lossless network that Rocky or Rocky V2 needs. Choose TCP. Make a decision based on what your installed base is, what you are comfortable with, what is the culture within the company. Because and finally, there's definitely use cases, right? Not everybody plays every sport, although there are multi-sport athletes all around there. But understand what your use case is. Is it OLTP? It is database applications. It is more hyper-converged. Are you running containers? Is real-time analytics, data mining? It depends on your use cases. That should drive the choice of fabric. So please, once again, reiterating my message, when you decide to scale out NVMe over the data center, please do not go by the shiny new object out there, the guy delivering the microsecond, sub-millisecond latency, because that is not everything that matters to your application. Stick with something that you are comfortable with unless absolutely necessary. Stick with what your culture is in the company. And finally, look at your applications, because end of the day, it's your applications that you as data center administrators or their suppliers are measured on. Thank you.
Thank you, Nishant. All right, so now I'm going to ask some questions of our panelists, and hopefully we'll have some time also for some questions from the audience. All right, so I'm actually going to start with Manoj, if you don't mind.
Sure.
So Manoj, of everyone on the panel, you're kind of in a unique position, which is that people want to talk to you more than everyone else. So, from your position in eBay, you get to see a lot of different offerings from all kinds of different companies that are interested in working with you as a hyperscale user. What are you looking at when you evaluate various offerings? What does the landscape look like from a customer perspective, and is it confusing?
Yeah, I'm going to perhaps use my both hats, and there is a technical hat that I do wear, and there is as a customer for this technology or the user of this technology and looking at our data center. So let me start with from our at an overall perspective, right? I think as what Nishant said is true. Okay, it just comes down to really what your requirements are and what your existing skill sets are and how your utilizations and how you manage the whole infrastructure. It depends on that, what your technology you deploy, which is true for eBay too, by the way. We have different types of use cases. We have mission critical infrastructure. We do have hyperscale infrastructure, and the requirements are significantly different. So the solutions could be different when I look at what I'm trying to build. But focusing on my primary job, which I look at hyperscale infrastructure, of course, we are going to be biased towards the things that we have in our hyperscale infrastructure, which tends to be somewhat related to the fabric, but more than fabric, it relates to how we manage our infrastructure, how our DevOps works, how our applications work, which tend to be very close towards Ethernet technology, TCP technology, or any other technology that can easily be deployed at a very high scale. So that's really the important aspect of it. So various solutions, when you look at it, first of all, is it something that we can adopt with minimum disruption? And before joining eBay, my job was on the other side of the bench, where I used to work at Intel and QLogic and other companies. And I developed a lot of features which I was extremely proud of and very excited about. And then I came to eBay and I realized, yes, but I can't use all of those, because the important thing is basically keeping the network up, keeping the data center up and running, driving the application performance, not necessarily the device performance. So point to what Nishant said was, yes, it may be excellent to get that sub-microsecond or sub-millisecond or sub-nanosecond latency for that matter. But if I cannot use it, it really doesn't matter. It has to be optimized to what we need. So coming and looking at these solutions, of course, Ethernet is something that we bias towards, but there are more important things that we have to also consider when I look at this technology. The moment we start disaggregating the storage, now the problem changes. Today we have storage inside our server, which may be, let's say, if I'm doing a SATA SSD which has, let's say, 330 megabytes per second throughput versus I put NVMe drive which has, let's say, 2000 or 3000 megabytes per second, the performance is way higher than I can utilize perhaps for most of the application. But you move it out and you put it like 4 terabyte, 8 terabyte or 16 terabyte drives, you're going to start aggregating the traffic because it disaggregated the storage. The problems change. The problems change where now I have to make sure that the performance can keep up with it. Now I have to make sure that my IOs are not going to get aggregated. So there was a presentation apparently yesterday talks about those, that you will start seeing the traditional issues that storage appliances have seen or storage arrays have seen. How do you maintain the quality of service? How do you provide determinism? How do I maintain the guaranteed performance for each application or each server that is going to? So those are the things that are going to come up when I start looking at these technologies. That can I achieve that disaggregation without compromising the application performance? So I'm not giving a specific answer which technology I prefer. Of course, the TCP, NVMe TCP is closest from the least disruption perspective. At the same time, we'll have to see whether it passes all the tests of being ready for the market without being something that is going to bring my applications down or the racks down in the data center, and allows us to maintain the kind of local storage expectation of the performance and isolation that we have today. Today in a single server, I have applications with, let's say, multiple 3 or 4 applications at a given point of time, maybe sharing that storage. Suddenly I move it out to the external storage, you got multiplied by at least 3 to 4. So we want to make sure that that kind of technology is still evolve. I think it's in early stage from that perspective, but I think it's a great start that we have with various technologies. RDMA is another thing which I do look at, Rocky V2, for example. And I think within one hop, it works fine. Its question is basically, can it scale to make sure that when I go across the rack, when you go to 3 racks, is it something that requires what was talked as a rip and replace, or more importantly, the functionality that exists in the infrastructure, but it is not being deployed. A lot of times people think we have priorities in the network. Why cannot just prioritize thing and put in the different? Not always, not for all the infrastructure, because they may not use it also. So it's kind of difficult for us to commit something which requires a significant infrastructure change without that kind of ROI. So this is where the RDMA technology may have a challenge. This is my technical hat on, not necessarily saying it's eBay view necessarily, but RDMA technology to go across multiple racks would require to show that it is something that can be easily adopted and can fit into the existing infrastructure without significant changes. TCP has a promise of basically delivering that because that's what it runs today. TCP can bring in another challenges also, and we'll have to see how that manages that, because this is a storage traffic. In the disaggregated storage for the kind of use case that we talked about, it's something that we are trying to look like a local storage. And this is why the point I was trying to make is that our view is basically rack as a compute makes it easier, a smaller domain that to address with it.
Thanks. So to follow up, I have a couple follow-up questions for our other panel members related to what you brought up, Manoj. So the show has a lot of demonstrations of NVMe over TCP/IP, and really kind of question for you, Kamal. So why TCP/IP? I mean, people kind of talked about it, right? Existing infrastructure, but is this really a new technology, or is it iWarp rebranded? And when is this technology going to be real? And is it, does it truly fit into existing infrastructure? Are existing NICs on all the clients able to function with disaggregated storage TCP/IP? So I'm going to touch on that.
Thank you. Yes, that's an excellent question, and as we've heard before, it's a matter of a bunch of things. How much comfort customers have with what's already in their environment? Have they been working with TCP? As all of us know, TCP has been ubiquitous, whether you've been at home talking to your service provider via your computer, whether you're in the data center, whether you're in the cloud environment. TCP is everywhere, and we've gotten comfortable with it. And especially in the data center space, there are skill sets that cater to that. As you look at additional protocols, whether it's Rocky, for example, or having a lossless fabric or something that requires RDMA, it often requires a rip and replace for existing opportunities, or if you're going for something completely new, you can think about that, but then your comfort level again comes in. And as Manoj was saying, you have to also look at where the constraints are moving. Now you've gone to very low latency interconnects in environments such as NVMe over fabrics, but if you're trying to do that over protocols such as Rocky, you have to look at your overall infrastructure. Are you looking at a single hop talking to a single top of rack switch? Are you going to make multiple hops? How will this work in that type of environment? So all these things have to be considered. And again, coming back to your comfort level, what do you know best? What problems do you know how to solve? If you end up with some operational issues, and then look at it from that perspective as opposed to just running after the new shiny object.
So, you talked about RDMA being rip and replace. So, a question for Nishant as our really networking expert on the panel. Pull up your chair. So, RDMA, it seems like it's a standard, but then, it seems like it doesn't all interoperate together. So, what is the state of affairs on RDMA? Is there a future where RDMA interops across vendors, or where do you see RDMA going, and is that a hindrance to adoption of the technology?
So first of all, at least what I would say, Jeremy, is that...
Sorry, no softballs today.
The way Jeremy is treating me, it feels like I'm at the airport. I'm the last one to present, and I'm sitting in the middle seat in the airplane. But going back to his question, in RDMA world, whether it's Ethernet-based RDMA or traditional InfiniBand omnipath like RDMA fabrics, there is interoperability between vendors, and a strong effort is being made by vendors and industry consortiums to make sure that different vendors' RDMA fabrics like Rocky from vendor 1 and Rocky from vendor 2 do interoperate with each other. And you can rest assured that if you decide to choose Rocky or iWarp and you build a multi-vendor fabric, interoperability is not going to be a challenge. Everybody works hard. We understand that it's not just one vendor's RDMA NICs that will sit in a data center. There will be multiple vendors, and interoperability between a type of RDMA fabric is not a problem. Now, there are unfortunately multiple RDMA camps, and the two dominant ones are Rocky as well as iWarp. Rocky and iWarp do not talk to each other. And I see absolutely no roadmap ahead, and maybe other panelists can correct me, of iWarp talking to Rocky. The two technologies, the way they are built, the way they talk to other similar people, Rocky and iWarp will not be able to talk to each other. So you need to decide before you start building and scaling out NVMe, what will be your choice of fabric, pretty much. There's no turning left or right later on.
Thank you. Yaniv. Okay. So, did you want to comment on the interconnect?
Yeah, I would actually.
Yeah, go ahead.
So maybe just to add a little bit to, I think, what Kamal said and Nishant said. First of all, from our experience, we are running with RDMA from different vendors. We're building a software layer, so we work with whatever our customers have from a hardware perspective, and we use RDMA also. And we see NICs from yourselves under the various different names that you've gone through, and from the other leading vendors. And there's really we don't see any real interoperability problem when you're working within RDMA. I think that one of the two options that you mentioned today, at least, is much more prevalent than the other. And in a way, sort of maybe it's not a great thing not to have choice, but sometimes when there's a clear standard, it does help simplify that choice. Going back to the TCP versus RDMA argument, I don't actually think that there's an argument. You can run both of those options if you have the right software across your network. And you can choose for which applications to use which. You don't necessarily have to use RDMA for everything. It doesn't make sense. Same as you don't necessarily have to hook everybody up with a 100 gig link. You can use for some 10, and for some you can do 25 or 100. You can mix and match in a way. But if you have the right software in place, that you can go and use TCP/IP where you think for areas where you don't necessarily want to put in RDMA, and then for other areas, you definitely do need RDMA. I mean, one of the things that really rocked the NVMe Express world over the past, I think, 18 months has been the whole IO determinism problem that has come up from the rack scalers. And they're talking about the 99th percentile, eking that, keeping the latency low even on the 99th percentile. It's important if you're running large-scale applications that run across multiple nodes, because that 99th percentile suddenly becomes your average when you start talking to lots of disks for that same query. So that becomes a really major issue. Now, if you go and say, for those applications, I'm gonna live with NVMe over TCP because it's easy from a rollout perspective. All that jitter that the SSD guys have gone to a tremendous effort to clean out, you're just bringing that back in with TCP. So you really need to have that your environment and your software layer really needs to give you the choice there, and not necessarily there's no wrong and right. You got to have that flexibility.
Yeah, it's interesting. It's like I speak as an SSD guy, but we spend a lot of time trying to get that 99.999 percentile latency to be clean, and then if you are going to many disks over TCP/IP, sounds like TCP/IP is very easy to deploy into existing networks, so it's great for bringing the technology to market quickly without a lot of barriers, but then at the same time, you may not be able to take advantage of the latency distribution, as Yaniv's point. So you touched on this in your presentation, in the slide where I think you mentioned Accelero's SDS kind of supports a converged infrastructure and disaggregated infrastructure, right? I get a lot of questions from people who are confused, I would say, about, well, if you look at today's trends, hyperconverged infrastructure is actually hugely popular. And you see it with solutions like vSAN from VMware, Nutanix, Microsoft. I know you also have an SDS. These solutions generally are direct attached SSDs that are pooled and shared. And you touched on a little bit, but maybe you can go into a little bit more depth if you don't mind. Comparing kind of hyperconverged infrastructure solutions to a disaggregated storage model, and which is better, when, where, why?
Sure. So thanks for the question. One of the things that people really like about converged, and especially hyperconverged environments, is that it's like TCP. It's a well-known beast. It's very easy to manage especially when you buy it from a single vendor. It tends to be a little bit more expensive, and maybe you don't get the best performance. But it's something which is easy to manage operationally. When you start saying, okay, but I need a little bit more performance, or I can't afford to pay all of that, and I still want to start using other things because I have high performance workloads, or because my management is pushing me to reduce costs, then you start looking at, okay, so maybe I don't do necessarily one vendor hyperconverged. I start putting things together, and it becomes a little bit more complicated. And then you go and say, okay, maybe I can even just work bare metal if I know, or use Kubernetes, some of the more modern things which are lighter weight on the CPU, and I've got some management techniques. But then I start using my storage. Instead of having the hyperconverged software running it for me, I need to start looking for alternatives, and I want to continue making them efficient. And when people start doing that, then they end up saying, okay, but if I'm already going to operationalize the ability to go and pool things, maybe I just build a pool of storage instead of keeping it locally. And that makes things even easier, especially in very dynamic environments. So a lot of it comes back to performance versus operational. I think that's what Manoj was mentioning before. Operationally, it's much easier to disaggregate. If you can find a solution that works for you from a performance perspective, then it makes a lot of sense to disaggregate your storage. It makes it much easier to scale compute versus scaling storage. The problems are, does it actually fit the bill? So, TCP is great if you don't really need a lot of performance. When you start needing more performance, you start looking for other things. Disaggregated is great if it meets your performance requirements, If it does meet your performance requirements, it's actually even better. Just put it on separate racks. Make it entirely composable from that perspective. But when you start looking at it, do I need better performance? And the performance isn't always from an IOPS perspective. It's usually actually from a latency perspective more than anything else. It's actually usually the tail latency more than just the latency itself that becomes really, really important. We've heard it from several different hyperscalers that the thing that they're most worried about is not the latency itself; it's a jitter in that latency, and that really kills the end user experience. At the end of the day, they're all looking to get the best end user experience and to bring in as much operational knowledge or artificial intelligence almost in real time. And that all comes back to the end of the day, it comes back to tail latency. So if operationally you can get the tail latency that you need, that's the choice that's best for you. The easiest thing from an operational perspective that will fit your performance requirements.
Okay. Brandon, how are we doing on time?
You're at the end of your time, but
Okay.
something after this, so you guys can keep on going, answer additional questions.
Sure.
People need to move on as well.
Yeah, I don't know. I think, maybe I'll just let the panel take over.
I'm going to be selfish, and since I got a lot of people who are interested in storage and NVMe, would quickly run a quick poll if you guys don't mind. If I had to ask a question, if you had infrastructure to take care of your own infrastructure, how many of you guys are comfortable technologically or deployment-wise with RDMA? Okay. All right. Thanks. And this is one of the things that I keep thinking, right? It's a great technology. Question is basically, can we make it easy for people to use it in that infrastructure which is already established today?
I just have a comment. I have a customer that's trying to blend TCP and RDMA in the same deployment, and so they're requiring.
Maybe I can make a comment to that. I think most likely the NVMe or TCP solution that your customer is using probably is all software based and not offloaded to a hardware. See, we have to understand that if you want to compare two things, you want to make fair comparisons. On one side, we talk about RDMA and NIC, in which RDMA is done entirely on the NIC, and then we want to compare that with TCP and talk about tail latency when doing everything in software. And to me, that's just not fair comparisons. And I do strongly believe that the world for NVMe or TCP perhaps will look very similar to iSCSI, where we will see a lot of hardware offload on the target side of things, if you know what I mean by target, the storage array side of things, while the initiators will likely still run software TCP, right? And
that's really the point, right? Is that it's not too difficult to put that new accelerating NIC into the target, because you're probably deploying some new storage nodes without having to go into every server and put a new NIC in thousands of clients. That's kind of the point of why TCP is easier to deploy, but then you'd still roll out the hardware accelerated version.
Where multiple clients are going into one storage array, I don't think software TCP is going to cut it. Not with NVMe, no.
Yeah, so that would be the next evolution, is we do some sort of.
Come down to the Toshiba booth in the show hall, and Kamal will be happy to show you our TCP offloaded solution. Right.
Anything else the panel wanted to say?
I had one question, and that is for Manoj. See, we all talk about making sure storage is out from the compute, right? But then we have a couple of choices. There is a full service provided all-flash array. Let's put that for a side as of now, right? People who want it really want it. The other two options is either use a FBOF, right? No storage services, or other is to use some kind of intelligent FBOF, right? It could be ones coming from you guys or from Webscale and things like that. So how does somebody, I'm not asking just specific to eBay, how does somebody make a decision? End of the day, the apps need the storage services, right?
Yeah. Yeah, it's a great question, because I think to kind of extend what Jeremy had asked before, how is NVMe TCP not IWARP? Similar, one could say, how is disaggregated storage no different than SAN? And if you look at from distance and wink a little bit, perhaps it's kind of similar. The important difference is exactly what Nishant you brought up, is basically the storage services. Where are the services coming from? for hyperscale infrastructure, you will see that most of the applications have developed with most of these services inbuilt into the applications, right? So it's the easiest way for anybody to do disaggregated storage, basically not change that, keep the storage service at the top. However, one could always argue that there is more efficiency the way traditionally things are done in the SAN infrastructure, but but you're starting to draw boundaries differently. That's really fundamental thing. The boundaries are being defined on the storage services here. The core goal for disaggregated storage in the simpler hyperscale infrastructure would be to allow the storage to be shared within a particular domain, which may be a rack or a network bubble or whatever it may be. But storage services still belong to the applications. Take an example. Let's say if you're running Mongo today on the local storage, you're doing 3 replicas or n replicas on the shards and what you're doing. You don't want to change that, because if you change that, there's no way you're going to use the disaggregated storage. Easiest way to say that disaggregated storage, keep the services on the top. Over long run, I believe the applications will adopt the most efficient solution. Yes. Over long run, but
Yep. Thank you for saying that.
Okay. So I'd like to thank my panelists. It's an amazing group of panelists that I pulled together here. So thank you.